Hi everyone, my name is Selvi. I'm working as an assistant professor in the Department of Mathematics in S.A.E. Engineering College. This is a GATE syllabus of probability and statistics. So in this, today I'm going to discuss the GATE questions on the topic exponential distribution. So we know that distributions are of two types, namely discrete distribution and continuous distribution. So first, now we'll go for the definition of exponential distribution. Now what is exponential distribution? It is a continuous distribution that often concerns the amount of time until some specific event occurs. So what is event? Actually, outcome or set of outcomes resulting from an experiment. So what is the use of exponential distribution? There are various uses. Here, exponential distribution is used to predict the waiting time until the next event occurs, such as success, failure, or arrival. So these are real life applications of exponential distribution. So first one is queuing theory. We model the time between arrivals in a queue, such as customers arriving at a bank or calls coming into a call center. The second is reliability engineering. Time until failure of a system or component, such as light bulbs or mechanical parts. Next is the survival analysis. Time until an event occurs, like the failure of a product or a time to death in a medical studies. Physics is decay processes like radioactive decay. So these are the real life applications of exponential distribution. So for example, exponential distribution can be used to predict the amount of time it takes a customer to purchase in a store. For example, another example is it can be used to predict the amount of time until an earthquake occurs. So these are real life application examples. So now we'll go directly to the definition of exponential distribution. So actually exponential distribution is definition is a continuous random variable capital X is said to follow an exponential distribution with the parameter lambda if its probability density function is given by f of x is equal to lambda e power minus lambda x greater than 0 and 0 otherwise. Here lambda is a parameter. This is the only parameter of the exponential distribution. So these are very important formulas we must know before doing the problems in exponential distribution. So mean of x is nothing but a exponential random variable. Mean of x is mu is equal to 1 by lambda. The variance of x, it is represented by sigma square, is equal to 1 by lambda square, and standard deviation of x is nothing but sigma is equal to 1 by lambda. Next, very important, probability of x greater than k is e power minus lambda k. So these are the four very important formulas we must know before doing the problems in exponential distribution: mean, variance, standard deviation, and the probability of x greater than k. And a very important property, memoryless property of exponential distribution. If x is exponentially distributed with parameter lambda, then for any two positive integers s and t, probability of x greater than s plus t given x greater than s is equal to probability of x greater than t. That is, the probability of an event occurring in the future is independent of the past. So this is actually the meaning of the memoryless property of exponential distribution. So now we go directly to the problems. So first problem, a continuous random variable capital X has a probability density function given by f of x is equal to 2 into e power minus 2x, x greater than or equal to 0 and is equal to 0 otherwise. The mean and variance of x are, so we were given four options, so we have to find the mean and variance. So first we have to list down what is given in the question. Here capital X, it represents a continuous random variable following exponential distribution. The probability density function of exponential distribution is given by f of x is equal to, as we know, this is a PDF of the exponential distribution. Now comparing this probability density function with the given function f of x, we have lambda is equal to 2. So question is, we were asked to find the mean and variance. So we know the formula of mean is 1 by lambda. So therefore it is equal to lambda is 2. So it is equal to 1 by 2. Now variance of x is 1 by lambda square. It is equal to 1 by, substitute lambda is equal to 2, so 1 by 2 squared is equal to 1 by 4. So therefore the answer is 1 by 2 and 1 by 4. So therefore the option is, answer is option B, 1 by 2 comma 1 by 4. So in this problem the PDF is given and we were asked to find the mean and variance. Now problem number 2, if a continuous random variable capital X has an exponential distribution with mean 0.5, then probability of x greater than 1 by 2 is. So in this problem, the mean is given to be 0.5 and we were asked to find the probability. And we were given 4 options. So first of all, we must write down what is given the question. So given mean of the exponential distribution. So we know the formula is, mean of the formula is 1 by lambda, that is equal to 0.5. So if you want, you can make it 0.5 as 1 by 2. So 1 by lambda is 1 by 2. So therefore lambda is equal to 2. So we were asked to find the probability of x greater than 1 by 2. Already we have discussed that probability of x greater than k is equal to e power minus lambda k. This is the easiest formula. So now write down P of x greater than 1 by 2 is equal to. Now comparing these two, we have k is equal to 1 by 2. So this is equal to e power minus lambda value is 2 into k value is 1 by 2. So 2 will get cancelled. We get the answer as e power minus 1. So therefore the answer is option A, e power minus 1. So in this problem, we were given the mean, that is a 1 by lambda value, and we were asked to find the probability value. So in order to find the probability value, we have used this formula. Next, problem number 3 is the number of parameters in the exponential distribution is option A 2, option B 3, option C 1 and option D 0. So we know that the parameter of the exponential distribution is lambda, which is greater than 0. So therefore we have a single parameter, therefore option is answer C 1. Next, coming for problem number 4, let Z be a exponential random variable with mean 1, then probability of x greater than 2 given, probability of z greater than 2 given z greater than 1 is option A. We have 4 options A, B, C, D. So what do we have to write? What are all the things given? So here Z represents the exponential random variable. Then it was given that the mean of Z is 1. So therefore we know the mean of the exponential distribution is 1 by lambda, which is equal to 1. Therefore lambda is equal to 1. So we were asked to find the probability of P of Z greater than 2 given Z greater than 1. So using the conditional probability, P of A by B is equal to P of A intersection B by P of B. So A is Z greater than 2 and B is Z greater than 1, which is equal to P of A intersection B divided by P of B. Now this is equal to, if we take intersection for Z greater than 2 and Z greater than 1, obviously the intersection is Z greater than 2. So therefore we have P of Z greater than 2 by P of Z greater than 1, that is probability of Z greater than 2 by probability of Z greater than 1. So we know the formula, probability of x greater than k is e power minus lambda k. So apply the formula here, this is equal to e power minus lambda into, here the k value for the numerator is 2 and for the k value for the denominator is 1. So when you take the denominator value to the numerator, we have e power minus lambda. So we know that lambda is 1, therefore this is equal to e power minus 1. So remember e power minus 1 value is 0.3678. Therefore the answer is option D, 0.3678. So in this problem we are using the concept conditional probability given the mean value of the exponential distribution. Next, coming for the 5th problem, the lifetime of a component of a certain type is a random variable whose probability density function is exponentially distributed with parameter 2. So here given the parameter of the exponential distribution, so therefore parameter is nothing but lambda, so lambda is given to be 2. In the previous problem the mean is given, so mean formula is 1 by 2. Here the parameter directly given just 2, so therefore lambda is equal to 2. So we were asked to find for a randomly picked component of this type, the probability that its lifetime exceeds the expected lifetime is. So we were asked to find the probability that the lifetime exceeds the expected lifetime. So first of all you list down what is that random variable. Here x represents the lifetime of a component of a certain type. So we know what is lambda, that is a parameter 2, and so when we know the lambda, we can write what is mean. So mean is represented by expectation of x, which is equal to 1 by lambda is equal to 1 by 2. So we were asked to find the probability that the lifetime exceeds the expected lifetime, that is probability of x greater than 1 by 2. So this is the expected lifetime, x greater than 1 by 2. So now in order to find out this probability, we are going to use this formula. P of x greater than k is equal to e power minus lambda k. So therefore P of x greater than 1 by 2 is equal to e power, what is lambda? Lambda is 2 into 1 by 2. So therefore answer is e power minus 1. So answer is option A, e power minus 1. So in this problem, the parameter is given. Now coming for problem number 6, the time required to repair a machine is exponentially distributed with parameter lambda is equal to 1 by 2. So here x represents the time required to repair a machine, and also the lambda is given to be 1 by 2. What is the probability that the repair time exceeds 2 hours? So we have to find the probability that the repair time exceeds 2 hours, means probability of x greater than 2. So exceeds in the sense we have to find out x greater than 2. So the same formula we are going to use. P of x greater than k is equal to e power minus lambda k. So probability of x greater than 2 is equal to e power minus lambda is 1 by 2 into k value is 2, this is equal to e power minus 1. So the answer is option C, e power minus 1. So in this problem, the parameter lambda is given directly and we were asked to find the probability. So remember, whenever we were asked to find the probability of some x greater than value, we can use this formula. Probability of x greater than k is equal to e power minus lambda k. So this was problem number 6. Next, problem number 7. The length of time a person speaks over phone follows exponential distribution with mean 6. What is the probability that the person will talk between 4 and 8 minutes? So we were given 4 options. So first we must list down what is given. Here capital X represents the length of time a person speaks over phone, and also given that mean of the exponential distribution represented by 1 by lambda is equal to 6, therefore lambda is equal to 1 by 6. So we were asked to find that the probability that the person will talk between 4 and 8 minutes, it is equal to, so probability of x lying between 4 and 8. So between 4 and 8, therefore it is probability of 4 less than x less than 8. So here x is a random variable between 4 and 8. So therefore we have to use the formula integral f of x into dx. So integral f of x, what is f of x? So f of x is nothing but the density function of exponential distribution. So therefore that is lambda into e power minus lambda x into dx. Here the lower limit is 4 and the upper limit is 8. So between 4 to 8. Now substitute the value of lambda. Lambda is 1 by 6. So also in the power 1 by 6. Now before integration you take the 1 by 6 constant outside. Now integrate this. So integral of e power minus ax is e power minus ax divided by minus a, that is minus 1 by 6. What is a value? A value is minus 1 by 6. So after integration substitute the limit. Upper limit is 8 and lower limit is 4. Therefore e power minus 8 by 6 minus e power minus 4 by 6. Now the denominator will get cancelled and we have minus 1 the denominator. So after calculation we have 0.24982. So therefore the option is answer C, 0.2498. So in this problem mean is given and we were asked to find the probability between two numbers, that is between 4 and 8. If so remember always, if you want to find the probability of x greater than, so we must use this formula P of x greater than k is equal to e power minus lambda k. So other than this x greater than k, we have to use the formula integral f of x into dx. So now coming for problem number 8. The time required to repair a machine is exponentially distributed with parameter lambda is equal to 1 by 2. What is the conditional probability that a repair takes at least 10 hours given that its duration exceeds 9 hours? So first, what is given? So given lambda is given directly to be 1 by 2. So we know the memoryless property as we have already discussed. Probability of x greater than s plus t given x greater than s is equal to probability of x greater than t. So we are going to use a memory property here. So first you write down probability that the repair takes at least 10 hours given that its duration exceeds 9 hours. So you are asked to find probability of x greater than or equal to 10. At least means greater than or equal to 10 given exceeds means we have to use a symbol greater than. X greater than 9 hours. Therefore P of x greater than or equal to 10 given x greater than 9. This 10 we can make it as 9 plus 1 so in order to use the memory list property directly. So now probability of x greater than s plus t given x greater than s is equal to probability of x greater than t, that is probability of x greater than 1. So comparing this memory list property with this, so we have s is equal to 9 and t is equal to 1, so therefore this is equal to probability of x greater than 1. So this is equal to, we know that what is probability of x greater than k value, it is e power minus lambda k. So my e power minus lambda value is 1 by 2 into k value is 1, therefore e power minus 1 by 2. So value of e power minus 1 by 2 is 0.6065. So therefore the answer is option A, 0.6065. So this is the only problem we are using the memory list property. Now coming for problem number 9. Assume that the duration in minutes of telephone conversation follows exponential distribution. F of x is equal to, find the probability that the conversion will exceed 4 minutes. So here the PDF, that is the probability density function, is given to be f of x is equal to 1 by 4 e power minus x by 4, x greater than or equal to 0. And we were asked to find the probability that the conversion exceeds 4 minutes. That is, exceeds means we have to use a symbol greater than. This is equal to, therefore this is equal to probability of x greater than 4. So probability of x greater than 4, we can use the formula, either the integral formula, integral 4 to infinity f of x dx, or we can use the formula, as usual formula, probability of x greater than k. So probability of x greater than k is equal to e power minus lambda k. So substitute lambda value. So we don't have the lambda value here. Okay, therefore e power minus lambda k, or else if we compare the exponential, that is a PDF of this with the standard function, we have lambda is equal to 1 by 4. So therefore we can either use the formula integral 4 to infinity f of x dx, or we can use the formula x greater than k e power minus lambda k. Here lambda is not given explicitly, but when we compare the PDF of the given function and the exponential distribution, we have lambda is equal to 1 by 4. Okay, so therefore we can either use this formula or we can use this integral 4 to infinity f of x dx. So integral 4 to x greater than 4 is x greater than 4. Greater than 4 means 4 to infinity f of x dx. So write down what is f of x. F of x is 1 by 4 e power minus x by 4 dx. So when we integrate, we get the integrate and substitute the limit, we get the answer is e power minus 1. So we can use either e power, probability of x greater than k is equal to e power minus lambda k, or we can use the integral f of x dx. So whichever we find it easy, we can use. So for the answer is option A, e power minus 1. Next, coming for problem number 10. Time between consecutive arrivals at busy gas station follows an exponential distribution with mean value 5 minutes. What is the probability that the time between arrivals is less than 3 minutes? Here given the mean of the exponential distribution is to be 5. The main formula is 1 by 5 is lambda is equal to 5. Therefore lambda is equal to 1 by 5. So probability that we were asked to find the probability that the time between arrivals is less than 3 minutes. So this is equal to probability of x less than. So less than means it is x less than 3. So since we were asked to find probability of x less than 3, this is a formula we can use. Integral f of x into dx. So since less than 3 means upper limit is 3 and the lower limit obviously it will be 0, f of x into dx. Now what is f of x? So f of x, we know f of x equal to 1 by lambda into e power minus lambda x. So f of x is equal to lambda into e power minus lambda x. Okay, so this is f of x. Here lambda value is equal to 1 by 5. So So lambda value is 1 by 5. Substituting 1 by lambda into e power minus x by 5 into dx. Before integration, you take this 1 by 5 outside. So after that, you use the formula integral of e power minus ax is e power minus ax divided by minus a. On substituting the limit, we get the answer as 1 minus e power minus 3 by 5. So for the answer is option D, 1 minus e power minus 3 by 5. So here the mean is given and we were asked to find the probability of x less than 3. The problem number 11, the lifetime of a certain type of light bulb follows an exponential distribution with mean value 1000 hours. What is the probability that a randomly selected bulb lasts more than 1200 hours? So here the mean of the exponential distribution, that is 1 by lambda, is given to be 1000. Therefore lambda is 1 by 1000. We were asked to find that a probability that a randomly selected bulb lasts more than 1200 hours. So more than means we have to use x greater than 1200. So we know the formula, probability of x greater than k is p of e, x greater than k is equal to e power minus lambda k. So here comparing, k value is 1200 and lambda value is given to be 1 by 1000. So therefore we have e is equal to e power minus 1 by 2. Therefore the answer is option C, e power minus 1 by 2. Problem number 12. The random variable capital P follows exponential distribution with mean value 0.2. What is the expectation of P square? So this is a different problem from the other problem. So here capital P is a random variable following exponential distribution. So given mean of the exponential distribution as 0.2. So we know that these are the notations. Expectation of P is equal to mu is equal to 1 by lambda. So these are the different notations of mean, and mean, we know the mean formula is 1 by lambda, which is given to be 0.2. Now from this mean we can find the variance. So variance of exponential distribution formula is 1 by lambda square. So 1 by lambda square is equal to mu square. So therefore variance of P is equal to 0.2, the whole square is equal to 0.04. So mean of the exponential distribution is 0.2 and variance of exponential distribution is 0.04. So from the given data we have these two. Now we were asked to find what is the expectation of P square. So expectation of P square, we know we can find it only from this formula. Variance of P is equal to E of P square minus E of P the whole square. So we know what is the variance, 0.04, which is equal to expectation of P square minus expectation of P 0.2 the whole square. So now you substitute, it is nothing but 0.04. So therefore you bring this minus 0.04 to the left hand side. Therefore you will be getting expectation of P square is equal to 0.08. Therefore the answer is option B, 0.08. So this is the expectation of P square. So therefore the given the mean, we were asked to find the expectation of P square. This is also a very important problem. Next, problem number 13. The failure rate of certain mechanical component follows an exponential distribution with a rate of 0.002 failures per hour. What is the probability that component fails within 500 hours? So here X represents a failure rate of the certain mechanical component. So given rate of failure is 0.002, that is represented by lambda. So we were asked to find probability that the component fails within 500 hours. So within in the sense we have just less than. So therefore we have to find probability of x less than 500. So therefore we have to use the formula integral f of x into dx. So less than 500 means the upper limit is 500 and the lower limit is nothing but 0 for the exponential distribution. So now what is f of x? So f of x is, so we know the PDF of exponential distribution, that is f of x is equal to lambda into e power minus lambda x. So lambda, this is f of x, we are using here lambda is equal to 0.002. So lambda into e power minus lambda x into dx. So before integration, you take the constant outside. You use the formula integral of e power minus ax is e power minus ax divided by minus a. So when you apply the limit, we get the answer as 1 minus e power minus 1. Therefore the answer is option A, 1 minus e power minus 1. So So coming for problem number 14, the time it takes for a computer server to process a request follows an exponential distribution with a rate parameter of 0.005 requests per second. What is the probability that the server processes a request in less than 200 milliseconds? So here also, like the last problem, the rate parameter is given to be 0.005, that is lambda is given. So we have to find the probability the server processes a request in less than 200 milliseconds is nothing but probability of x less than 0.2. That is, we have converted. Here the rate is given in terms of nm per second, and here milliseconds is given, so we have converted this in seconds. Therefore, probability of x less than 0.2. So x less than means we have to use a formula integral f of x into dx. So f of x is lambda into e power minus lambda x, lambda value 0.005. So before integration, take this constant outside. Apply the formula e power minus ax is equal to e power minus ax divided by minus a. So on substitution of the limits, we have 1 minus e power minus 0.001. So this is option C. So here also, that the last problem, rate is given and we were asked to find the probability of x less than 200 milliseconds, that we have converted. Therefore p of x less than 0.2. Next is problem number 15. The time to pass through a security screening at an airport follows an exponential distribution. The mean time to pass through the security screening is 15 minutes. To catch the flight, a passenger must clear the security screening within 15 minutes. What is the probability that the passenger will miss the flight? Here x represents the time to pass through a security screening at an airport. Here the mean of the exponential distribution is given to be 15. That is 1 by lambda is equal to 15. So if a lambda is equal to 1 by 15. We have to find the probability the passenger will miss the flight is equal to p of x greater than 15. So passenger will miss the flight means we have to find probability of x greater than 15. So we are going to use the formula probability of x greater than k is equal to e power minus lambda k. So k is 15 and lambda is 1 by 15. So therefore when you substitute, we will be getting the answer as e power minus 1. Therefore the answer is option B. We know value of e power minus 1 is 0.3678. Coming for the problem number 16, let capital X and capital Y be two exponentially distributed and independent random variables with mean alpha and beta respectively. If z is equal to minimum of x comma y, then the mean of z is given by. So here we have two random variables, there is two exponentially distributed random variables x and y, and their mean is given to be alpha and beta. That is, mean of x, it is represented by 1 by lambda 1 is equal to alpha. Therefore find out what is lambda 1 is equal to 1 by alpha. Next, mean of y is represented by 1 by lambda 2, it is given to be beta. Therefore find out lambda 2 is equal to 1 by beta. So here the condition is z is equal to minimum of x comma y. So if we have z is equal to minimum of x comma y, the formula of mean of z is 1 by lambda 1 plus lambda 2. So actually this mean only we have to find. So if we have z is equal to minimum of x comma y, mean of z formula is 1 by lambda 1 plus lambda 2. So we know what is lambda 1, 1 by alpha, lambda 2 is 1 by beta. So when you take LCM, it will be alpha plus beta divided by alpha beta, and we take the reciprocal, it will be alpha beta by alpha plus beta. So therefore the answer is option C, alpha beta by alpha plus beta. So this is a very different problem. Here two random variables is given and the relation is given, and we were asked to find the mean of this relation z. So this is the end of this session. I'll continue in the next session. Thank you.